Good morning, everyone. I'm Paola Zerilli from University of York, the coordinator of the SuperEye project. We are about to enter the final period of this project. It's going to finish at the end of this month. And we are working on the final deliverable. Is an Horizon 2020 CSA project. We have been focusing, as most of you now know, but welcome also all the people who are not familiar with this project just yet. We've been focusing on finding solutions for financing investment in energy efficiency in social and affordable housing, mainly studying 3 pilots in Italy, in Denmark, and in Slovenia. Our colleagues this morning, they're going to talk, they're going to give a brief presentation about that. We have been studying both these interventions from various points of view: technical point of view, environmental point of view, and financial point of view. So today we'll give you a flavor of and also policy point of view, obviously. We'll give you a flavor of the main findings of our studies so far. Just to oopsie, sorry, there is someone. Okay, so first of all, we are going to see our Danish case study, and we have our good friend Eric from the School Sustain in Denmark. Then we have Cristina David, Italian case study. Nina Pekar from Slovenia is going to talk about the Slovenian case study. And then our partner Tom from Element Energy is going to talk about the technological intervention for improving energy efficiency and what that means in terms of energy savings. I'm going to talk about the financial solutions that we have been studying for specifically for this type of intervention, and also not only for our pilots, but also for a couple more cases in Italy and Denmark that we observed through our survey. And then Noelia from CIRSE is going to talk about the environmental impact of this intervention, and our colleague Riccardo Coletta from APRE and also coordinator of the sister project Supershine is going to talk about the policy recommendations. Just a second, I stop sharing this. Oopsie. Okay. I just wanted also, before giving the word to Eric, I just wanted to focus your attention on our website, where we have already some of the results, but we are going to put more details in there very soon. I'm going to put the link on our chat. Just to give you an idea, the website is shared with Supershine, that is focusing on the district, on energy efficiency in the district, rather than just the buildings. In here, if you just click SuperEye, you have an overview of the project, but also about the interventions on the pilots. And if you go inside, You can see our analysis from various points of view. Sorry, this is super shine. I don't know why. Sorry, I clicked the wrong one. If you go in the pilots here, for example, Italy, you can see already the perspective from a technological point of view, environmental point of view. And then if you go at the very bottom, you have already the cost-benefit analysis, which we are going to update with more findings soon. Okay, thank you very much. So now I'll leave the floor to Eric, and then we'll thank you, Eric. You want to share your screen? You are muted. You're muted, Eric.
Unmute. Yeah,
Okay.
sorry. It was just trying to control two screens at once. That was just too much for my competences, unfortunately. Okay. Well, thank you for the floor. I will present two of the pilot from Denmark. There are four pilots, but they are more or less the same. So in regards of the time, I will try to take you through two of them. And then I will also try to tell you a bit about ESCO 2.0 and why we are trying to use that or utilize this in Denmark. When we look at why we should use ESCO, it is because in Danish housing associations, we have a tenant democracy where the tenants has to decide themselves if they want to go further with a retrofitting project or energy retrofitting project. And here we can use ESCO as a measure to make the uncertainty in projects lower and thereby enabling the tenant democracy to take the right decisions, and right meaning that they are willing to take a bit of a risk in terms of what are the savings when they are making energy retrofitting projects. So this is the main challenge that we are trying to move beyond using the ESCO approach. Because we have to have this dialogue with the tenants that when they look at their housing cost, typically people are talking about their rent. But we also try to tell the story about that it's not about rent, it's about housing cost. And can we lower your water or electricity or heating bill, but increasing your rent as long as your housing cost is the same, then you're home safe. And actually you stand a bit better because you're more resilient, because your rent is fixed, your utility bills, they can vary, and we have seen that with the energy prices over the last few years. So that has helped us in this dialogue. But this is what we're trying to communicate to the tenants, that we want to talk not rent, but housing costs. Then we have developed the ESCO approach. Typically, ESCO has been on technical installations, PV panels, energy management, charging stations, and so on. But we have tried to develop a way, ESCO 2.0, where we also look into the climate shield. How can we combine those PV panels or lighting system with a low payback period with window, doors, installations that have a longer period of payback, and trying to combine those enable to make projects better and bigger and make a more deep retrofitting projects. Sorry, I will see if I can. So this is why we call it ESCO 2.0, is we are moving beyond just technical installations in this combination, and that is what I'm trying to show you. So one of our pilot cases is this housing association department of low attached houses. When we have a look, it is 164 accommodations, and they have estimated electricity consumption of nearly 500,000 kilowatt hours. So what we would try to do is they have retrofitting project already in the pipeline. They need new windows and they need some technically upgrades. So here in this specific case, we were looking at, can we install PV panels and thereby subsidize the retrofitting project that the department already wanted to do. So we looked at installing 46 smaller PV panels, and then utilizing the savings into a bigger loan than the initial investments. And when we look at the project, we can see we can make a saving of 164,000 euros a year installing these PV panels, and it will cost them about 1.6 million to invest in the PV panels. When we then run the numbers through our ESCO machine, we can see if we have 164,000 euros to pay back a loan. If we then say, okay, the PV panels have a payback time about 12 to 15 years, depending on the interest rates. But if we extend that period to say 20 years, we can actually use the savings to lend the department 2 million euros, more or less. And that will then give the department 400,000 euros right in their hand to use to the other parts of their retrofitting project. So here we are not just using the ESCO to finance one initial investment, but actually trying to see if we can use the ESCO model to finance other things in the retrofitting projects that the department already want to do. So we can provide extra, and I will say a 20-year loan for PV panels that has a life expectancy of 30 years. That is with a good margin in terms of, is it a safe investment for them. So this is one way of using ESCO to provide extra funds into a project. And I'm sure if we take a look more broader at the project, okay, some of the installation projects and new windows, that would also provide some energy savings, so we could do even more or finance even more of the project with the ESCO. But the Housing Association wanted us to focus on how can the PV panels subsidize an already planned energy retrofitting project. So this is one of our cases from Denmark. Then we have a more classical ESCO way. This is at another housing association. Here we are looking at 36 residents and departments, and we were trying to see, okay, what kind of projects or energy savings projects could we find looking at it. And we could see that there were potential for installing heating, intelligent steering. There were also a possibility for PV panels, and then we could find some water savings installing new bathroom or new toilets. And this was the project that the housing association wanted. And then they said, okay, but if you finance it through an ESCO, how can you finance it, and is it also possible to get some extra funds? So we made two calculations. One saying, okay, if we look at the investments, we can finance the principal of roughly 74 euros, and with the savings we can have a payback time of 15 years, and then you're home safe. Then the initial energy saving has paid for the whole investment, and the heating intelligence system and the PV panels have a longer life expectancy than this, so that will be a profit afterwards. But if we try to extend the payback period, as we also did in the other case, saying, okay, we can take a loan for 20 years, then utilizing the energy savings, we can lend the department 217,000 euros, and then free up around 40,000 euros that they can use in other areas. And other areas could be interesting, seeing, okay, if we want to do the free initial investments, can we use the 40,000 euros to give the tenants something extra, something luxurious, so they will vote yes to the PV panels and to the intelligent steering? That could be a subsidy for new kitchens or new bathrooms, so that we can lure them, so to say, into making the right decision. So even though we are using the excess money not for a green project, then we are using it as a bait, so to say, to give them the possibility for investments. So this is our approach to ESCO, making it more safe, because we make a guarantee for the savings, but also trying to provide extra cash or extra funds for the departments to make initial or extra investments. And that can be in more green projects, or it can be into luxury things that make the decision easier to go through the tenants' democracy. That is the big obstacle, as I started to elaborate about. So this is the pilot cases that we are looking into in Denmark, and we have made 2 similar cases.
No, thank you, Eric. Yes, thank you so much for the explanation. I just wanted to, you can stop sharing if you like, Eric.
Okay. Yeah.
I just wanted to also say that we'll be collaborating with Sustain and Desco Sustain, where Eric works for Supershine, because we are going to have a crowdfunding campaign where we are going to sell some of these contracts. So a combination of these contracts. I'm going to talk about the details of these contracts during my 10 minutes. But the collaboration with Eric is hopefully ongoing. So we'll see more details in a few minutes. Thank you, Eric. Probably we'll get all the questions at the end, guys, if you don't mind. So now I'll give the floor to Cristina Davi from Mater Trieste, who is going to talk about the Italian pilot. Please, thank you, Chris.
Yes, Paola, here I am. Okay, I am Cristina Davi. I am a manager in Mater Trieste. Mater Trieste is the social housing agency of the Trieste area. We are an Italian, of course, social housing agency. We managed about 1,500 buildings in the Trieste area, and we are supervised by the regional governance, our Regione Friuli Venezia Giulia. In Super I project and also Super Shine project, Trieste is the Italian pilot. And so now I give a short presentation of our site. In Super I project, there are 2 sites as a pilot, and I share my presentation. Okay. It's okay.
Yeah, that's fine. Thank you.
Okay, okay. Yeah. Okay. And so first, I would like to focus about the motivation that pushed Ate Trieste to be here, to be in Super I and Super Shine project. In Italy, the social housing has a lot of critical problems. And so I could explain the main problems are the bureaucracy process into our intervention, insufficient funds for the renovation and the new constructions, the old and inadequate buildings, made from the point of view of the energy consumptions, and also with the high maintenance cost. We have a lot of problem with our waiting list. A lot of persons are in a long waiting list for access to our housing, and also we have a lot of problem with our legislation that is very complicated, and all the rules, a lot of rules are very difficult, very complicated to apply. And so we believe in the PPP tools to give us help to face this problem. And that's why we are here, and we are here in that kind of European project to find help to face our main problem. And now I give a short presentation about our two complexes that are involved in the Super I project. The first one is the complex of Via Boito Street in Trieste. There is a complex. This complex are also pilot in our Super Shine project at a district level. In Super I, we have one building. The building is very, very old, and we have been demolished and rebuilt as new. The current situation is a situation with 16 apartments. The apartments are very, very, very minimal in dimension, and there is also the presence of materials containing asbestos, and the plant are very, very outdated. At the moment, the energy costs are the 40% of the annual resident income. That means that the inhabitants are at high risk of energy poverty, and so we had empty the buildings to demolish and rebuild it. The new buildings, in that case, one building, will have 8 apartments, and so not so minimal as dimensions, and also the buildings will be equipped by, of course, all the modern plants and application. Of course, the PV panels, the water recovery, the head recovery, and also blown and groove roofs and vertical wall and vertical carrying wall. In the intervention of Paola Zerilli and also of the other person, there will be a description about also this intervention. The second one is the complex of Montasio in Trieste. Here the situation is quite different, because we have to refurbish these buildings with an total energy requalification. One of the characteristics of this building is that there are a lot of private owners that lives in these buildings, and this is very important from the point of view, as we will see, we heard about Paola Zerilli, from the point of view of the financial instrument. This building is a complex with 215 housing units, and all the plants were installed in 1998. The new solution, and so the refurbishing intervention, will of course reduce, has the target to reduce the energy needs from the point of view of cost, and also from the point of view of pollution, of course. With the list of intervention you could see in the slides: the external wall insulation, the power units replacement, and of course with PV panels, and also a lot of actions to improve the comfort inside the apartment, inside the building. And so that's all from my side, and
Thank you, Cristina. Thank you, Cristina, for giving us a very detailed description about the Italian pilot. And you can stop sharing if you like. And then on this basis, very shortly, we would hear about the technical interventions and also environmental impact and financial instruments. You can stop sharing, Cri, if you like.
I can't do it.
There is the button at the end.
No, okay, but
I don't know whether Marta can stop the sharing. Marta? Marta? Okay, thank you. So now I give the floor to Nina, who is Pekar from Slovenia, is going to talk about our last pilot. Please, thank you, Nina.
Yes, hello to everybody. Can you see my share screen?
Yes, we can, thank you.
Okay. So Slovenia was a partner in this project with our demo project in Trbovlje, city Trbovlje. It was a small building with 26 units. It was built in 2005. We, Housing Fund of the Republic of Slovenia, is the owner, and the rest is from the company, who is also owned by the Housing Fund of the Republic of Slovenia. This building was proposed for a demo building because there was a need to do the renovation of the facade and heating system to make it energy efficient building. In the apartment, these apartments in the buildings are intended for non-profit rental and affordable rental. So for the people with average to low income in Slovenia. And the cost of energy was high to the poor thermal insulation that was on the building when it was built, and the high heating cost due to the high price of the gas supplier. And the average heating cost was around €5 per square meters per month. So there was, it was supposed to, we have to implement the thermal insulation on the facade and also on the attic and the basement floor. Then it was selected a heating optimization solution to replace the existing gas stoves with more powerful gas stoves, individual gas stoves in the apartment to heat the apartment, and also then to install the new electric boilers for preparation of hot sanitary water. In order to meet the technical requirements of the regulation of efficient use of energy in the buildings in Slovenia, it's recommended to make a thermally insulated facade, which is 18 centimeters thick. The all cost of the project documentation and the professional supervision, construction and installation works that has been done, it amounts approximately to 500,000 euros in the buildings. Also, the fund, so Housing Fund of Republic of Slovenia, with this company that has their own share in the building, we submitted the application to obtain non-refundable funds from EcoFund. And this application was approved. So we, for these interventions that were made on the buildings, it was approved in amount approximately 32,000 euros for doing this energy rehabilitation of the building. And now the people inside they're living have a little lower cost for heating, less less energy. It's more energy efficiency, and there is no loss of heating. So they are now really satisfied because of the previous high costs of energy they have. So this is one of positive intervention that was made in the this demo case. So yes, this is all for the Slovenian case. Thank you.
Excellent. Thank you, Nina. Thank you for your presentation. Now I leave the floor to our colleague Tom Stowe from ERM. It used to be called Element Energy, but now is Environmental Resources Management, who is going to talk about the technological side of the intervention that are planned for each pilot. Tom?
Thanks, Paula. Yeah, hopefully you can all see that. Yes, so as Paula says, what we did was kind of try and capture the energy savings that are associated with the work the housing associations were going to do, find a sort of means to do that, and then sort of iteratively refine those models and those estimates, working with the housing associations. So it's been interesting. It's also been sort of quite a big challenge, and I'm just going to kind of talk through now how that's gone and what we kind of found. So kind of just to go very high level, basically for a given building, you're going to lose heat to the environment dependent, and the amount of heat you lose is going to depend on how good your insulation is and how cold it is outside. So we needed a model that could grab the weather data. So, okay, so the outside temperature is 5 degrees. You want it to be at least 15 degrees inside, so that there's a 10-degree difference. And then you multiply that by the amount of surface area that's exposed to that temperature, and you also multiply it by something called the U value, which basically says for a given temperature difference, how fast is heat going through the wall or the window or the floor. And then once you can do that, you can compare a sort of before and after version of the house where you've improved the windows, where you've added insulation to the roof. And then you can, if you subtract the sort of new energy savings from the old, then you work out how much energy you've saved. And on that basis, at some sort of fuel cost, depending on how you're providing the heat to the building, you can work out what the associated saving is, what the carbon emissions you've avoided are, and other economic considerations too. So then calculate the payback period, those kind of things. So we developed this, what we wanted was it's sort of building that model is fine. What you need to do though is you need to find a way for sort of non-building physics experts to be able to tell you about the U value, about the sort of the quality of the fabric of their buildings. Getting the weather data is easy. there are lots of kind of online tools where you can just say, all right, so tell me what, how cold it was every hour in, the middle of Denmark. And then we can kind of plug that into how much heat you would have lost. But we also need to understand what the building, the size of the building and what it's made of. Is there insulation in the roof? Do you have double glazing, triple glazing, those kind of things. So yeah, these were the models then that we used, the data sets. So we've got hourly weather time series data, so you can work out, how cold it is in Trieste, in Denmark, in Trubolier, and work out sort of how fast your building's going to be losing heat. The building thermal performance is looked up on something called SIBSI, so people would choose from a kind of drop-down menu or a kind of big long list of, the walls made of, I don't know, hollow bricks, and there's a layer of sort of insulation between the two walls, or there's an air gap, or they're made of expanded concrete with, I don't know, XPS foam on the inside, those kind of things. And then we'd sort of work out what the U values were based on that. And then in terms of kind of fuel use and carbon emissions, most of the schemes in the project pipeline just have kind of gas heating, so that makes it very easy to work out what the cost and the carbon emissions are of every unit of heat you avoid. In Denmark, a lot of the schemes have district heating. That's sort of a little bit harder because the economics and how the heat is generated in those schemes kind of varies. So in most cases, we've used a kind of indicative value of about 5 euro cents per kilowatt hour of heat delivered. Obviously, gas prices have moved up and down quite a lot during the course of this project. And I think, as in Henrik's presentation, the sort of projection of future power prices is obviously important, these considerations, and difficult to do. But yeah, that's the challenge. And yeah, with the model, there's been this kind of iterative refinement. So sort of saying, okay, so this is what the list looks like. Can you tell us what your building looks like from this list? And people would say, well, we use different building materials in Denmark, so we've had to kind of expand that list. Or, here's the EPC certificates, or here's what our kind of typical fuel bills are like. Compare that to what the model's saying, and then that allows us to kind of to believe in our model results, better, and sort of to have greater confidence that the model is reflecting what's kind of really going on. Okay, yeah. So this is a data set provided by an organization in the UK called SIBSI, which is a group of building engineers, and they make kind of data sets like these available. So this is the sort of thing that our list would look like. So people would say, what kind of windows do you have? They pick from that list. And then we'd say, okay, on that basis, we expect the U value, the rate at which heat is lost through that component, to be the value in the right-hand column. So this is kind of almost like a translation piece between sort of non-experts and then the building physics. Yeah, and we also looked at PV yields, because in a similar way to the way you can get temperature data out of sort of big data sets that you can query online, you can also work out how much sunshine you're seeing in those locations, and on the basis of those, we can work out how much a PV panel on the roof there would generate. Obviously, that then feeds into questions about, like, well, how much electricity are you avoiding pulling in from the grid? What price are you pulling that in at? How much electricity are you exporting to the grid when the panel's producing more than you need? What price are you getting paid for that? Again, so a lot of the kind of association analysis with PV yields is sort of pretty indicative, but we have the kind of technical capability to do that. We just sort of need to iteratively, working with the users, sort of work out what the relevant numbers are. Okay, so Henrik talked a little bit about the Danish pipeline. Danish pipeline comprises the vast majority of all the participating schemes. I think there are 15 schemes in total, comprising about 2,000 flats, just under 2,000 flats in total, I think, across a couple of locations in Denmark. Most of those have been built since the kind of 1980s, and Danish build standards are pretty good. So the kind of the sort of potential to improve the building fabric is not massive, and typically you're looking at kind of quite expensive interventions to do that. Also, given that they're on heat networks, the the opportunity to decarbonize the heating there is very good, because you only have to replace like the big gas boiler in the center of the scheme, rather than kind of going around and doing everyone's individual gas connections. So in terms of the interventions at the schemes, most of the one we really thought made the most kind of sense, and I think that has kind of been picked out to move forward with, is replacing the windows, moving to kind of triple ply windows. There's minimal kind of disruption to the residents. You can do them kind of all at once, and yeah, so all the other the walls, roof, the other components of the building are already kind of built to pretty good standards. So for kind of purely energy terms, there probably isn't a huge amount that you'd want to do there. Again, PV on the roof. Denmark is actually a pretty good sort of solar market. You get sort of reasonable generation, particularly in the summer. But Danish grid energy is already about 80% renewable. So in sort of environmental terms, the case there isn't kind of overwhelming. Just moving on. Late in the project, we had 2 additional schemes sort of fill in our questionnaire and provide the kind of technical data in the sort of final version of the template. These schemes are in Copenhagen, and one in Kjellerup, which is in Jutland, sort of in the south center of the country. And they suggested a load of things that they were thinking of doing, which included improvements to all the fabrics, and these are pretty drastic improvements. So they're already at kind of EPC B and C, which is pretty good. But yeah, they're suggesting kind of spending over €1 million at both schemes to improve all the kind of building fabric, and would reduce their energy consumption for heating, we think, by about a factor of 5. So come down to sort of less than 20% of their current usage if they do all of it. Yeah, it's not. I mean, we haven't sort of spoken to them, so we're not sort of really clear how seriously.
No, yes, sorry, just to clarify, Tom, thank you. These are additional data that we have collected through our survey, but yeah, so we just wanted to show here some results of applying our models and our analysis to additional cases that are in different areas compared to our pilots, but in the same country. Thank you. Go ahead, Tom, please. Thank you.
Yeah, as I say, so we haven't engaged with these. They have provided estimates of the fuel savings, which agree with our model results, and presumably are based on sort of more detailed modelling of the building. So that's encouraging. But yeah, we just wanted to say sort of here that that this model is sort of something that can be picked up by sort of other housing associations and used to sort of do the initial economic assessment for these kind of questions. Yes, in the Italian case, we've heard about those already, and obviously, Boito is going to kind of be entirely redeveloped. But yeah, we think that there's a Trieste obviously has a kind of mild Mediterranean climate, but there's a reasonable amount of heating in winter, and so the economic case for improving the windows, walls, and roof is actually pretty good. Payback periods are sort of not long. Yeah, so we think the sort of proposed solutions make a lot of sense, and also obviously have kind of other benefits in terms of improved quality of life, improved environmental case. Again, in the Italian case, 2 schemes filled in the questionnaire, and we assessed those. They're based right in the south of the country, in Naples and Calabria, and the heating demands associated with those buildings are very modest. So we think that they're probably paying less than €250 a year for gas for space heating. So even if you're making quite dramatic improvements to your heating demand, which we think they are if they're going to go ahead with all these interventions, then you're just going to, instead of paying €250 a year, you're going to pay €70 a year. And so the actual just the amount you're saving just takes a long time to pay off the cost of the intervention. Yeah, there's obviously, given that they're in the south of Italy, there's probably also some cooling. There may be some cooling demand that's required in the summer. Given that they have gas heaters, it's not clear that they also have kind of electric air conditioning. But if they do, you're definitely going to save some energy there, and you're going to improve the livability of the apartments. I mean, in the survey that they filled in, they've suggested that the payback period is about 25 years. So, clearly these are not being proposed on a kind of purely economic basis. And then the final thing to say is that actually, given that they have kind of heat pumps and solar thermal to generate hot water, this case may actually be overstating their savings, because if you're getting hot water for free from the sun, or if you're generating power and then using it to run a heat pump, your sort of per unit costs for space heating will actually be lower. Again, something that it would be, if we'd kind of been able to interact with them, something we could have dug into. Yes, okay, so Nina's just talked about Slovenia. Again, we ran the model there, and again, it looks like the kind of the big opportunities are the proposed improvements to the wall, and maybe some considerations around the energy supply and renewable energy. Again, all kind of very initial at this stage. Yeah, that was all I had. I think that's my time. Does anyone have any questions or anything they wanted to?
We'll pick up all the questions at the end. Thank you, Tom. Yes, there was some question about the behavior, people's behavior, how this can have an impact on the energy savings. But if you can answer at the end, we'll finish with the presentations first, please. Yeah.
Okay.
You can also put something in the chat. I already added something in the chat, Tom. You can stop sharing if you like.
Yes, okay, all
right. You can start answering in the chat if you like, and then if you keep this in mind, we can talk about it at the end. Okay, thank you. So now I'm going to talk about the public-private partnerships that we have been analyzing as solutions for funding this type of intervention. I'm going to share my screen. Just one sec. Yeah. Okay. Can you see my screen? Oops. Yeah. Okay. Sorry, I don't know why this thing keeps appearing here. Okay. So what we have been proposing is some type of something like a one-stop shop that actually we are going to develop as a matter of fact through Supershine, the next step from SuperEye. Which is also part of the New Bauhaus initiative. So the buildings that we are considering for SuperEye are about 25 buildings for Denmark, 7 buildings for Italy, and 1 building for Slovenia. The cost of the proposed intervention varies from 25 million in Denmark to 220,000 euros in Slovenia. As you can see, both in Denmark and Slovenia, the funding rate already of the funding that is already available is pretty high, 72% for Denmark, 80% for Slovenia, but still there is space for finding additional funding. In Italy, the funding percentage what is available in theory is 50%, but we have been asked by our Italian pilot to consider also the case where there is no funding. The problem is because it takes there is lots of bureaucracy in Italy in order to assess this funding, and also now the social housing associations they're not most of them, they're not allowed to borrow money anymore because directly because it is considered too risky. So that's, but we'll talk about this in a minute, the specific cases. For the proposed energy efficiency interventions that Tom has been talking about, they would lead to about 50% saving, sorry, it's going backward. 50% in Denmark, 66% in Italy, and 70% in Slovenia. It's just because the starting point in Denmark is pretty high. It is a bit worse in Italy and Slovenia, so there is more scope for energy savings. So the contracts we have been analyzing. So basically, what has happened is that Tom has calculated through his model, the one that he just presented, the possible energy savings from the interventions that have been planned, and we have been using those in order to classify and evaluating these public-private partnership contracts to see what were the possible return on investment for the various parties involved. So we have analyzed all of these contracts, but what I'm going to present today are the results for the top two performing, that is the share saving contract and the guarantee saving contract. So in both the two contracts, the counterparts are ESCOs and social housing companies. In the case of share savings, is the ESCO that is borrowing the money. For our case, we have considered a contract where if the energy savings are higher than the minimum guarantee savings, the minimum guarantee savings are the cost of debt in order to borrow money for this type of investment. So if these are higher than the minimum guarantee savings, they get 35% of these additional savings. Otherwise, they get zero. So it basically is because the major risk for the investment is taken by the ESCO, is borrowing money directly. And ESCO, if the energy savings are higher than the minimum guarantee savings, they get the minimum guarantee savings plus the 65% of the extra savings. Otherwise, they get the energy savings. Obviously, these percentages, 65%, 35%, they can be adjusted by the two counterparts on the basis of the specific case and their needs and their interest. In both the two contracts, the ESCO is in charge of the maintenance and operating cost. For the case of the guarantee savings, is the social housing company who is borrowing money. It can be also that depending on the size of the investment, some of the money is available through national funding or European funding. So in this case, because is the social housing company who borrows money or puts the initial investment down. So if the energy savings are higher than the minimum guarantee savings, they get the minimum guarantee savings plus 20% of the extra savings. Otherwise, they get the minimum guarantee savings. And ESCO, if the energy savings are higher than the minimum guarantee savings, they get 80% of this difference. Otherwise, they get this difference, energy savings minus minimum guarantee savings. Again, we are going to put all the details of these contracts on our website. So here, I just wanted to give a visual idea, straight idea about the best performing contracts for both the social housing company and ESCO for our pilots. And we can see that for the Danish case, most of the time, the best performing contracts in terms of return on investment is share savings. But in the case of after the link, where guaranteed savings is performing best, but it's still share savings is a good choice as well. But they will get an higher return in the case of guaranteed savings. There is only one case is for Ammertor that there is for the social housing company and ESCO. There isn't a matching. What is performing best for one is not performing best for the other, but will be a second best. So in that case, what will happen is that the two parties they will need to reach an agreement or slightly adjust also the percentages of the sharing of the energy savings through the contract. In the case of Italy, in the Italian case, for Montasio, where what is planned is refurbishment of the existing buildings, the share savings is the best one. For Boito, where the plan is to knock down the existing buildings and build them again from scratch and building them with very high energy efficiency. There isn't a matching between the two contracts, but again, they will need to reach an agreement between the two parties. For the case of Slovenia, also there isn't a matching, but share savings and guarantee savings are the ones who are performing the best for the two parties. Again, also for that case, they will need to reach an agreement, the two parties, to see which contracts to go for. Just again, to give you an idea about the energy savings. So we have considered the energy savings for all the interventions altogether, but also we have considered the energy savings for single interventions. Obviously, from a financial point of view, sorry, will be best to do all the intervention together, but sometimes this isn't just not feasible, either because it takes would be too disruptive for the tenants and for people living in these houses, or it's just too costly and cannot be done all at once. So for that case, we have been asked by our social housing companies, our partners, to consider also the return on investment and the energy savings that are correlated to the single intervention. So for that case, you can see it also makes sense that the interventions on the walls is the one that leads to the highest energy savings. We have also we have also evaluated the payback period for all the interventions altogether and also for the single intervention. And we see that the highest, the longest period is 15 years correlated to the windows, the window intervention, because obviously this energy savings associated to those is the lowest. So for that case, we have been considering, because it's not really feasible to have a contract that is going for such long period, we have considered rolling contracts for, say, 5-year period, for example. So here I'm giving you again just a flavor of what will be the return on investment for example, for Italy. Ahmed, okay, for Montasio and Boito, for both the two buildings, but we have been considering exactly what I was talking about before. In the case where the interest rate where the parties can borrow money is a low one. So green loan interest rate is to 38%, for example. For the case where bank loan interest rate is about 5.06%. And in the case where the investment is considered high risk by the financial institutions, so about 9%. So what comes out is that even in the worst case scenario, say in the case where the interest rate is high, we have a return on investment that is higher than the risk-free interest rate, but obviously is lower than the interest rate they are paying for borrowing money. But this has been taken into account in our evaluation. Because basically it really depends on the financial institution how they are evaluating the riskiness of the investment. But let's say that we land with a bank loan interest rate of about 5%, that is already quite high. You can see that the return on investment looks pretty good for both the social housing company and ESCO and also the private owners. In the case of Montasio, we have a percentage of private owners for some of the buildings, for some of the flats. For the tenants, what we have considered are the energy savings that are transferred to them by the social housing company. So the same holds for Denmark. Okay, so we have done exactly the same what I was talking about. We have considered the case where they can borrow money at a green loan interest rate about 3.15%. Some also middle ground that is about almost 6%, and 8.46% in the case where the financial institutions they consider the investment risky. But say that let's look at the middle case. So even in that case where the bank loan interest rate is quite high, the return on investment for all the parties that are involved is pretty high. Okay, so just consider that every time it really depends on who is taking the risk of investment as well. So for Slovenia, again, we can observe something similar, that in the case of quite high bank loan interest rate, we have still a very good return on investment for all the parties that are involved. Again, we are going to put all these results on the website. Obviously, in our evaluation, we had to make some projections through our financial models for future macroeconomic variables such as inflation rate and interest rates, and all these they are taken into account for all the period for the payback period of the investment. And here we are presenting the results for all the investments altogether. So for we also considered here, I'm just presenting briefly some results about the additional cases that we collected through our survey. Just again, an example. So for the case of Southern Italy, so the funding need for the case that we are considering is quite low, is 70,000 euros. And the buildings have currently energy performance certificate C, and what they are considering are roof insulation, replaced district heating with heat pump, solar PV, wastewater heat recovery system, and advanced lighting control. So for this case, again, we are the best performing contracts are share savings and guaranteed savings. There isn't a matching between what is best contract for the ESCO and for the social housing, but again, it's something that they will need to agree upon in their negotiations. But again, both the two contracts, they are about sharing the risk of investment. So here we have we are presenting what are the return on investment for the two parties. So say that we land in the middle range where where the interest rate for borrowing money is about 5%, there's still a very good return on investment, about 10% for the social housing company and almost 10% for the ESCO in the case of share savings, almost 12% for the social housing company and 8.5% for the ESCO in the case of guaranteed savings. In this case, obviously, the social housing company will get higher return because it's taking is borrowing money directly. And the other case that we considered again is to see what are the results of applying our models in cases that are different from our pilots, our original pilots. So for these buildings in central Copenhagen, the total estimated renovation cost is about 1 million euros. And they are planning an improved resource consumption with heat changer and also some PV panels installed and lower operational cost and energy savings. The funding needs are about 200,000 euros. In this case, we are observing that the case of guarantee savings is the best possible contract for both the two parties. Okay, so it's the case where the social housing company is borrowing money. So, and again, even in the middle case where the interest rate for borrowing money is 5%, both the social housing company and the ESCO, they are getting a very good return on investment. Okay, that was all from me. I'm going to answer the questions in the chat in a minute, and now I'll leave the floor. Also, if you have additional questions, I'll answer at the end. I'll leave the floor to our colleague Noelia from CIRSE, who is going to talk about the environmental impact of the proposed interventions. Thank you, Noelia.
Thank you, Paula. Give me 2 seconds, I share my screen. Okay, can you see my screen now?
Yes, thank you.
Okay, thank you. So hello everyone, and thank you for being here today. My name is Noelia Pérez, and I'm representing CIRSE in this final webinar for SuperEye project. Today I will give you through the environmental and social perspective through the energy efficiency renovations in SuperEye project. Slide. So the main objective of today's presentation is to outline the environmental and social impacts observed in each pilot country, focusing on Italy, Denmark, and Slovenia. And we will see specific country results in environmental impacts, social life cycle assessment, and life cycle assessment. These assessments plays a crucial role in aligning with the SuperEye project, as well as with the European climate action and energy efficiency targets. So first, I'm going to talk you through the environmental impact assessment. So this assessment evaluates the potential environmental consequences of our energy renovation projects and focus on key factors such as CO2 emissions, waste management, and material efficiency. The environmental impact assessment helps us to ensure that our renovations are not only energy efficient, but also environmental responsible, complying with the European guidelines. On our environmental impact assessment findings through the 3 pilot countries, we can tell that in Denmark we see a strong national commitment to reducing the CO2 emissions that is supported by comprehensive subsidies and green loans for energy efficient renovations. Denmark also prioritized the waste management and the recycling within the renovation projects, helping to cut down the construction related waste. They have initiatives such as the energy savings agreements, and it helps both the private sector and the public sector to, through involvement, fostering a culture of sustainability across the stakeholders. In Italy, the environmental assessment have shown substantial CO2 reductions thanks to the integration of renewable energy like solar panels and improving the building insulation. These upgrades not only reduce the emissions, but supports the waste reduction and material reuse, and they contribute to the nation's Green New Deal objectives. Italy's commitment to low carbon transitions and the environmental resilience is even evident through our findings. In Slovenia, the focus on the transition to a low carbon economy is largely funded by the Eco Fund, which supports deep environmental projects, and waste management is getting to be integral on the renovation strategy of Slovenia. All of this is reinforced through public-private partnerships aimed to scaling sustainable practices. These combined efforts are helping Slovenia to accelerate towards low carbon goals. On the life cycle assessment, we evaluate the environmental impact over the full life cycle of a building, from construction and use to end of life disposal. By analyzing each phase, LCA ensures that our renovations are truly substantial at every stage of the project, and we can identify opportunities to minimize waste, emissions, and resource use. Here we saw that in Italy, the LCA results show significant energy savings, primarily through the efficient insulation and the heating systems that reduce the operational emissions. The life cycle impact further reduced by the integrating renewable energy sources like the solar panels and high efficiency windows. And these measures also reduce the environmental footprints while aligning with Italy's long-term sustainable commitments. On Denmark, the LCA findings emphasize the role of smart technologies in optimizing energy use. By implementing digital monitoring systems, Denmark maximizes energy savings throughout the building's life cycle. Denmark also is dedicated to end-of-life practices that support recycling in line with the National Green Building Standards. Slovenia, LCI findings highlight the emphasis on eco-friendly design with projects favoring low-impact materials and extensive energy-saving measures. The Eco Fund backs many of these energy renovations, especially for the low-income households. And they focus on the sustainable design elements, ensuring that the long-term environmental benefits across all the stages of the building life cycle. In this graph here, we've been analyzing the different materials of the measures that could be applied on the pilots. So we justify which ones are better than others, and when they cannot afford one of the materials that we suggest in our analysis, we give them a workaround of how can they improve that. Now I'm gonna talk you through the social life cycle assessment. For this approach, we focus on social aspects for the renovation projects, like assessing the impact on the residents' quality of life, energy affordability, and social well-being. And it is complementary to the rest of the analysis that we've been doing through the project as we were exploring these energy efficiency renovations in social housing. Social LCA gives us an insight of how these renovations affect not only the environment, but also the lives of the people they serve. And we analyze energy affordability, comfort, social well-being, job creation, health and safety, and community benefits. The findings that we obtained through our analysis it tells that in Italy, programs like the Superbonus 110% are creating a great social impact by reducing the energy cost for the residents while improving building safety through seismic upgrades that is quite a big issue in Italy. This not only benefits the environment, but also enhances the safety and the quality of life of the residents. And it aligns with Italy's goals for resilience and sustainability. Denmark's approach includes subsidies designed to make the energy renovations affordable for lower income groups. And additionally, Denmark, through the energy savings agreements, involve local businesses, promoting job creation and community involvement. This inclusive approach amplifies the social benefits of the energy efficiency, improving the living conditions across a wider demographic. In Slovenia, affordability is a central focus through the Eco Fund. Low-income households can access energy-efficient housing solutions, reducing energy expenses and improving comfort. Public-private partnerships initiatives further enhance social benefits, ensuring these upgrades enrich vulnerable population and supports equitable access to sustainable housing. As the social life cycle assessment recommendations for Denmark, we found that it could be great to upskill workers for the installation and maintenance of high technology solutions and ensure that community engagement programs to ensure the social acceptance of the renovations. In Italy, we think that sustain the financial incentives that are already in place and expand the workforce training programs focus on green building technologies. And for Slovenia, increase public awareness on environmental, economic, and health and comfort benefits, and the implementation of advanced technologies like the smart homes integration. To conclude on the findings that we get through the supervised pilots countries, we can say that the findings from Italy, Denmark, and Slovenia illustrates how the energy efficiency projects can provide both environmental and social benefits by reducing emissions and enhancing energy affordability. These pilots contribute to significantly to the European climate goals, and as well, we continue to invest these initiatives. Our aim is to replicate these successes across more European member states and building a sustainable and inclusive future for all. For that, we have surveys where the other other people interested on have some insights of future renovations can get some results on how to proceed. For that, I'm gonna give you a wee taster of the first analysis done for 4 buildings, 2 in Denmark and 2 in Italy, through survey data collected through SuperEyes project. And here I just assess the environmental impact assessment, and I find out that for the Danish buildings, through the renovations proposed, can achieve significantly higher energy savings than the Italian buildings due to the larger scales of interventions. And also the harshest climate conditions require better insulation. The walls and heating and cooling systems contribute to the most energy savings, while the insulation and HVAC systems upgrades have a greater impact. Windows and the lighting provide a lower energy reductions, but they are still essential for the overall efficiency. And the LCA findings from the survey data is that on Denmark buildings located in central Denmark and Jutland, there is a higher global warming potential impact due to the reliance on foam insulation, and also one of the buildings that relies on gas heating systems. There is a moderate resource depletion, with the res integration having a strong impact, and lower water use, mainly through the insulation and the HVAC system upgrades. A moderate waste generation indicates better material efficiency than in Italy, because they have a end-of-life plan for recycling. The primary improvements areas in Denmark should be shift towards renewable heating solutions and use more recyclable insulation materials. In Italy, there is a lower global warming potential impact due to the better thermal mass and more efficient heating systems.
Thank you, Noelia. Thank you, Noelia. Sorry, we are running
It's okay,
out
it's okay,
of
no
time.
worries, Paola.
Thank you. We'll be
Thank you.
sharing our slides at the end of this meeting. Sorry, we are running a bit late. Thank you so much,
No
Noelia.
worries. Thank you.
Very, very useful. If you stop sharing, I'll give the floor to Ricardo about the policy recommendations, because, yeah, we are close to the end. Ricardo?
Yeah, so I'm here.
Can you stop sharing? Okay, thank you.
Yeah, good. So start sharing mine.
Ricardo from APRE is the coordinator of the Supershine project.
Yes, so well, hope you can see my screen. So just first of all, okay, see, this is the part of our job done in SuperEye. It's not me, but okay, I'm working together with my colleague Flaminia Rocca, which is in the meeting today. And well, okay, actually, it's not exactly the policy recommendation, but it's well, the main finding and gaps in proposal for improve the policy in the country involved in the SuperEye project, and as we're gonna see also in the Supershine. So I will spend just a few words. I will be very quick because okay, we are close to the end of the meeting, but just to let you know, we know the path we followed during our work together with our pilots and partner countries. So first of all, so fostering a dialogue to find the best solutions to be applied in our social houses districts. And the second part, it's but already well fully explained by Paola, is about the funding issue. So then we analyze well, funding reduction or all the bureaucratic obstacles that everyone experiences in everyday life in the sector, and finally how to involve actively the local community. So, and how the regulation and rules in the different countries can improve this process for all of them. So this is just an overview of what all the meetings and the activities we have done. So not focusing only in one single pilot. As you can see, in Italy, we experienced different cities and very different situation, but it was the same for in Barcelona and Denmark, for instance. But okay, every single country just follow its own path, but with the goal to collect information and regulation on the main issues I just showed before. So just some insights for every single country, for all the 6 partner countries, and there are some common, definitely some common points, and then some common critic points, and one of those is definitely the rules for getting and achieving funds, both from public and private sources. One main issue is that it comes from different countries, and you will see it is just to find the planning tools, which might involve the local communities in a decision-making process. So in Italy, we find this, and we are working on it. So not only in SuperEye, but as we will see in a while, also with the SuperShine project, which is the one I'm coordinating. And yeah, so as you can see, also in the United Kingdom, so the financial support to local authorities is one of the main issues we found it. And of course, the involvement and awareness. So with educational campaign, not only for the public, but also for the availability of technological solutions. So just for the general public, but also for the technical expert, it's one of the key insights. Let's go to the Denmark and Belgium, and we'll find some of the common points I just listed before. So the financial criticalities is, of course, as you can easily understand, one of the main issues. But not only, so the sharing of information and just for ease the process to apply energy efficiency initiatives or refurbishment activities in the social housing district. It's extremely important for the Danish, and we can find this also in the Belgium, because the sharing of innovative approach to renovation and best practices and models and replicable models. So find a way to make this easier for the local communities and for the building owner, and of course also for the public owner of the buildings. So finally, the last 2 countries, and I'll list here, are more focused on tools and regulation that will improve the engagement of the tenants. So again, a tool to support the decision process, and once again, so the financial risk. So we are coming back to the financial tools and support from the regulation in Spain as well. So, but okay, all these issues are really strictly linked, of course, to all the presentation you have seen so far, related to the financial, technical, or physical intervention, or the environmental impact of all the energy efficiency intervention and social housing. So what we are doing with SuperShine, so SuperShine will we collect the legacy from the SuperEye project. So part of the district are in common with the 2 projects, and we will try to replicate and increase the multiply effort of the SuperEye results in 3 pilots, so Trieste, Herning, and Riga, Latvia, which is new. So not involved in the SuperEye project, but we are not limited to these 3 lighthouses, because we will work, and we are currently working with 4 fellow cities, so Setúbal, Belgrade, Zaragoza, and Istanbul. And it's extremely important for us to working on tailored financial solutions, which is one of the main critic point we we find in not only in the 3 pilot, but also in the 6 countries. And so Supershine is a strong focus on it. And to conclude, so how we fit with the new European Bauhaus pillars in the Supershine project. So following the path already designed by the SuperEye project. So the net pillars together is to increase the involvement, the direct involvement of the citizens in all the process. So the design of the new common spaces or the energy efficiency solutions and the strong awareness of the local community. So we want to involve at a higher level the local communities in the decision process, or at least in cooperating with the decision maker. Sustainability, as already said, one of the main goals is to find financial support and financial solutions for our pilots and find solutions that should be replicated in our fellows and beyond. So that's one of the main goals. And of course, the environmental sustainability is inside, let's say, our activity, because we are working on energy efficiency. And finally, and it's strictly linked to the first point, so promoting community-led renovation, so involving the community, but with not only beautiful solution, it's aesthetically beautiful solution, but also with practical efficiency. So the efficiency, it's strictly connected to this beautiful pillar. And so what we want to assure to the local communities is that they are going to live in a place that in which they can restore a sense of belonging and in which they feel comfortable. So, but this project will still run until spring 2026. So still a lot of activities ahead to just keep alive, the work done in SuperEye, and maybe to build something else for the future. So thank you very much.
Thank you, Riccardo. Thanks. So I just wanted to say that thank you to all our speakers, obviously. Through the Supershine project, we will be applying and extending what we learned during the SuperEye project, and we actually are going to have a crowdfunding campaign where we are going to raise money for our lighthouse districts and eventually, hopefully, for the other districts, selling really our public-private partnership contracts in collaboration with the local ESCOs. So this is what is going to happen. So we'll allow other investors, financial investors, private investors, to participate in this investment. Also, I would like to invite whoever is social housing manager or ESCO in this meeting. Please feel if you are interested in having the analysis done with the same type of results. So possible technical intervention, environmental impact, financial analysis, and also policy recommendations. If you would like to have all these, please fill the survey as soon as possible and drop us an email, because we can also include you still in some of the results in our project, and we can also work on this through the Supershine project as well. Okay, so later on, we are going actually to have a one-stop shop through the Supershine project, for which we'll be charging for the analysis. But at the moment, we are not charging. So you are still in time to have this done for free. So just I've been trying to answer all the questions in the chat, but if you have any additional questions, please also feel free to email me. I'm going to put my email address in the chat as well. We can also have a short Zoom meeting, one-to-one, if you would like to discuss any specific tailoring of the analysis to your specific case. So, guys, do you have any quick questions before we wrap up? We are already, I understand we are 8 minutes late, but if you have any quick questions, we are here. No? No questions? Okay, so thank you so much for participating to this meeting. Please feel free to contact us in case you have any questions or you would like to collaborate with us for the future. We are also looking for new cases, new pilots to involve in possible new future projects. So just keep in touch with us. Thank you so much.